So I want to dig into a little bit of this idea of how do I figure out what possible zeros of a polynomial is. And so if you remember in class the other night, what we talked about was factors of this divided by factors of that. The last term divided by factors of the first term. And if you think about where that comes from, this is a cube, so we may be able to split it out into three linear pieces that look like this. We might not, but if we can, this x cubed, this 12x cubed has to come from this times this times this. X times x times x is x cubed. If these are just numbers, the largest we can get if we don't use all three is just x squared. So there's our x cubed, and whatever these numbers are have to multiply to 12. So they're going to come from that front multiplication. I can make the same argument for this one right here, that if these are just numbers here, those three multiplied together are going to give me that last term, that last 40. So these have to be multiples of 40. That's where this idea comes from. And it helps us, like I said, get possible roots for this. They aren't guaranteed roots, they're just possible. So if I look at this, I'm going to think about factors of 40. And it could be positive or negative, but things that multiply to 40. 1, 2, not 3, 4, 5, 8, 10, 20, and 40. So those are all possible roots, but it could also be any of those divided by any factors of 12. So 1, 2, 3, 4, 6, or 12. So this is my list of possible roots. And what I mean by that is take one thing from the numerator, one thing from the denominator. So 5 divided by 1 is 5. 5 could be a root of this. 1 divided by 3 is 1/3. 1/3 could be a root of this. Negative 10 divided by 2 is negative 5. So that could be a root of this. So it gives us all these possibilities. In this case, there's a lot, but this helps us work it on down. What I would do is I would then throw this in my graphing calculator and see if I can eyeball where the roots are, or at least where one of them is. And so I'm going to take advantage of the fact that I created this, and I'm just going to take a guess and say, I'll try 4. So let me see if 4 goes into this. And remember, when I choose 4, I'm saying that's what I'm factoring out, that x minus 4 right there. So 4, I'm going to do some synthetic division. 12, negative 41, negative 38, 40. It's all descending power, so I don't have to do any placeholders. So bring it down, multiply. God, now I have to add. Add, multiply, 28, and what's that? Negative 10, multiply, negative 40, 0. It worked. It's like a miracle. So it worked. That's good. I know that this is one of the roots. What I did was I factored that out, and I'm left with this, right? So what I have is x minus 4 times 12x squared plus 7x minus 10. So now I have to try and factor that. Or I could run it through quadratic formula. Thinking about factoring this, 12 and 10, I think it's going to be I'm going to split that into a 3 and a 4, 20, minus 6. How about 15 and 8? Make that one, yeah, that works. Great. So then I can get my zeros off of that. Set that equal to 0. Solve it. 2/3. Solve that as well. You're going to get negative 5/4, and we already found the 4. And notice that 2/3, yep, that was one of our possible. Negative 5/4, yeah, that was one of our possible. And 4, that was one of our possible. So this idea of factors of the last term over factors of the first time for all your possible roots totally limits down your number of guesses that you have to make.